Astronomers have long been fascinated by the possibility of an undiscovered planet within our solar system, often referred to as Planet 9. This theoretical planet could be lurking far beyond Neptune, potentially 5 times the size of Earth. For many years, scientists have been captivated by the idea of its existence, and now, fresh evidence suggests it could explain the peculiar movements of icy bodies beyond Neptune. But what makes Planet 9 so significant? Why is it important, and what have scientists uncovered about it? In this discussion, we'll delve into the science of Planet 9, explore the latest findings, and reveal how it could transform our understanding of the solar system. Let's start by examining the evidence that led scientists to propose the existence of Planet 9. The story begins with the strange trajectories of objects beyond Neptune, known as Trans-Neptunian objects, TNOs. These icy bodies, often residing in the Kuiper belt, display odd behavior that is difficult to explain unless there is a hidden giant planet exerting its influence. Back in 2016, Caltech astronomers Konstantin Batygin and Michael Brown observed that several of these TNOs shared similar orbital characteristics. These TNOs follow elongated orbits that bring them unusually close to Neptune, and then send them back into the far reaches of the solar system. If we think of the solar system as a giant disk, these objects don't stay neatly within that plane. Their orbits are tilted at sharp angles, making them outliers in our cosmic neighborhood. But here's the intriguing part. These TNOs shouldn't behave like this on their own. Something is guiding them. This unusual clustering of orbits, where the object's closest approaches to the Sun and their farthest points all align, led scientists to speculate about the existence of Planet 9. This planet's gravitational influence could be the key to explaining why these icy bodies move the way they do. What makes this evidence so compelling is that other explanations, such as interactions with Neptune or the gravitational pull of the Milky Way, the galactic tide, don't hold up under scrutiny. For example, recent simulations showed that the galactic tide alone can't push these TNOs into the orbits we observe today. But when Planet 9 was added to the model, everything fell into place. The planet's gravity perfectly matched the observed behavior of these TNOs. Let's take a closer look at how scientists are testing the idea of Planet 9 to solve this mystery. They've conducted a series of simulations, akin to solving a massive puzzle with millions of pieces scattered across the solar system. Each piece represents an icy object with its own unique orbit. Scientists ran these simulations to compare 2 scenarios, one where Planet 9 exists and one where it doesn't. In one set of simulations, the researchers modeled a solar system with no Planet 9 and only the gravitational pull of the galactic tide acting on the TNOs. What they found was that under these conditions, the TNOs couldn't be pushed past Neptune's orbit. The galactic tide alone was too weak to explain the orbits we see today. Then they added Planet 9 to the equation. In this model, a planet with about 5 times the mass of Earth exerts its gravitational influence on the TNOs, causing them to be slingshot past Neptune. The result? The simulated orbits closely matched the real-life orbits of the TNOs. This provided the strongest statistical evidence yet that Planet 9 is out there, hidden in the depths of the solar system. What's fascinating is that these simulations also help rule out alternative explanations. For instance, the idea that these orbits were shaped by a past encounter with another star doesn't hold up under the data. Similarly, the possibility of a small black hole influencing these objects seems less likely given the strength of the Planet 9 model. By comparing different scenarios, the researchers concluded that Planet 9 is the most plausible explanation for the strange behavior of the TNOs. This suggests that we still have much to learn about our cosmic neighborhood. If Planet 9 exists, it would be the first major planet discovered in our solar system since Neptune in 1846. This also raises new questions about the formation of planetary systems in general. If Planet 9 exists, how did it get there? Was it captured from another star system, or did it form in place, and we're only now discovering it? However, Planet 9 isn't just a theory built on recent evidence. Its origins trace back to earlier astronomical puzzles. Long before Batygin and Brown's work, astronomers noticed oddities in the orbits of objects like Sedna, a distant dwarf planet with an unusually elongated orbit. Sedna's orbit couldn't be explained by the known planets, which hinted at the gravitational influence of a hidden world far beyond Neptune. Interestingly, the idea of a hidden planet isn't unique to our solar system. In other star systems, astronomers have found planets that influence their surroundings in similar ways. For example, some exoplanets have been discovered because their gravity tugs on nearby objects or distorts the light from their parent stars. These so-called perturber planets share similarities with Planet 9, providing a fascinating parallel between our solar system and distant worlds. This planet could teach us valuable lessons about the limits of habitability in the universe. Even if Planet 9 isn't suitable for life, studying its characteristics could help us better understand the kinds of environments where life might thrive or struggle to survive. As we await further observations from the Vera Rubin Observatory, the prospect of finally uncovering Planet 9 remains tantalizingly close. Thanks for watching. If you enjoyed this video, don't forget to subscribe for more exciting space updates.